Welcome back to your learning journey in the statistics and probability for data science. So team, as we progress in today's session, we will understand about the skewness and the kurtosis which comes under measures of shape. So the agenda of this video is we'll understand about the concepts related to variance, standard deviation, and then we'll also understand about the concept of skewness and kurtosis and why it is important when it comes to data science. So let's get started and let's start by understanding this variance. Now, when we say variance, variance is a measure of dispersion. So I have already used it in our previous video when we talked about the hands-on session. So to give you a background about this variance, it's a measure of dispersion or a measure of spread. And here, this considers the spread of all the data points in my data set. Now, this variance is, I can say that I'll take the values, okay? I'll take the variance of my data in my data set. And once I take the variance, I'll take the square root of this variance. And this square root of the variance is called as standard deviation. Generally, when we are expressing the data and when we are expressing these dispersion, we represent it with the help of standard deviation. If I want to describe what exactly is this variance, variance is a mean square difference between each data point at the center of the distribution, which is measured by the mean. To give you an example, let's take up an example data. Let's say I've got some data like this. Okay, I've got some data points as 2, 7, 3, 12 and 10. So these are the values that I have got right here. Okay, these are the values of my data points. Now what is the variance? It's a mean squared difference between each data point and mean. So let's get started and let's find the value of mean. So what is mean? As you know from your previous learning journey, mean is nothing but sum of all the elements divided by number of elements that I've got. So sum 2 plus 7 is 9, 9 plus 3 is 12, 12 plus 12 is 24, 24 plus 10 is 34. 34 is the sum. And if I want to calculate the mean, so 34 divided by 5, which is equal to 6.8. Okay, so this is the value of mean. Next, in order to calculate the variance, so what I'll be doing right now is I'll take the difference. Okay, I'll take the difference of each and every data point from its mean and I'm going to square it. And once I add it, so that is the value of my variance. So let's do one thing. Let's use the Excel sheet itself that will help us in performing the activities in an easier manner. So the values that I've got right here are 2, 7, 3, 12 and 10. So these are the values that I've got with me. Next, I'll just start by performing the sum. Okay, so I'll say sum. So sum of all values. So this is the sum of all the values. Now what I'll do is I'll take the mean of the same. So mean is nothing but the average. I'll write it like this, mean. Okay, it's the average of my data points. So this is the average that I've got with me. Now in our first thing that I'll do is I'll take the difference squared. So I'll say difference squared. So difference squared is nothing but this value, okay, minus this value that I've got right here. So I'll have to take the square. So this is the difference. I'll just say it as difference as of now. I'll calculate the difference for each and every data point. Next, I'll say difference squared. So this is nothing but value multiplied by itself. So this is my difference squared. Now, once I have the difference, I'm going to divide by the number of data points that I've got. So here, if I say the sum, so the sum is 74.8. Okay, I'll say sum of difference. So this is the sum of my difference. Now, in order to calculate the variance, now for this value of sum, I'm going to divide by the number of data points. So variance is nothing but 74.8 divided by 5. Okay, divided by 5. That is the value of my variance. So in this scenario, I have calculated the variance by first computing the mean and taking the difference of every data point from its mean, squaring it, and then the mean of those squares. When I perform the sum and when I take the mean, so that will be my variance. So this tells me as how my data points are spread across the single value, that is a mean value. Now, if you look into our data set, okay, the variance is describing it as 14.96. But if you look into the range in our data set, the minimum value is 2 and the maximum is 12. And I'm saying that there's a variance of 14. It doesn't make sense, isn't it? So in such scenarios, what we do is we'll take the square root of variance. Okay, if I want to take the square root of variance, I'll do one thing. I'll say square root of variance, that is 14.96. So if I take the square root of variance, that is 3.86. Now that is my standard deviation. So standard deviation is square root of variance. Now it is much better when I'm trying to explain this. So I can now say that, okay, the values are spread across from the mean to the range of 3.86. Now this is what my standard deviation is. I hope you are now clear as why do we require standard deviation when we already have a variance. So variance, when we get it, the scale of this variance will be very large than the scale of my data point itself. In order to explain the variance, in order to explain the spread in an efficient manner, we calculate the standard deviation, which is a square root of variance. Now moving on, so we have the concept of measures of shape. Now, when we talk about this measures of shape, we actually have two measures of shape. One is skewness and the other one, what we call it as kurtosis. So the measure of central tendency, measure of dispersion that we have already seen. So this will help us to describe the distribution, but they are not helpful for us in describing the nature of distribution. In order to describe the nature of distribution, we use the two statistical measure, that is skewness and kurtosis. So what it does is it is going to compare the shape to the normal curve. Now this skewness and kurtosis are the two important characteristics of the distribution, and these are very much studied in the descriptive statistics. Now if I want to talk about this skewness, it's a statistical number which tells us if the distribution is symmetric or not. Now I'll say a distribution is symmetric if the right side of the distribution is very similar to the left side of the distribution, like the one that you see over here on the right hand, on this middle figure that you see right here. So the middle value that you see right here, middle diagram, so this describes the symmetric distribution. And here, in case of symmetric distribution, the mean value, median value, and mode value will be equal together. And in this scenario, the values of this skewness will be equal to 0. Now, if the skewness value is greater than 0, then we call it as a right skewed, or a right tail is longer than the left tail. We call it as right skewed distribution when the value of skewness is greater than 0. Now, if the skewness that have got, if it is less than 0, then in such scenarios, we call it as left skewed, or the left tail is actually longer than the right tail. So that is what we call it as a skewness in the distribution. So you can clearly observe the diagrams for positive skewness and the negative skewness in this given data set. Okay, so now that you have understood the working of the skewness, so now let's take a look into the another characteristic value, that is kurtosis. Now kurtosis is a statistical number, and this tells us if the distribution that have got, whether it is taller or shorter than a normal distribution. Now if a distribution is similar to the normal distribution, then in such scenarios, we will say that the kurtosis is equal to 0. And if the kurtosis is greater than 1, then it has a peak compared to the normal distribution. It has got a higher peak compared to my normal distribution. And if I've got a kurtosis less than 0, then it is flatter than my normal distribution. Here, under the kurtosis, there are actually three types of distribution. One is leptokurtic, where we observe the sharply peaked with flat tails, and it is less variable, which you see over here in this diagram with the red color. And we have got mesokurtic, and in this scenario it is medium peaked. And we have got platykurtic. In this scenario we'll have a flattest peak and it is a highly dispersed one. All right, so this was about the measurement of spread and the measures of shape in our given data set. So team, if you want to download the course materials which I have explained in this video, the source code which we have worked upon in our last video, so do check out the link in the description. So you can access everything from our website www.manifoldaIlearning.in. So thank you so much for watching, guys. And if you're new to our channel, consider watching this playlist from start so that you get the most of what is happening in this learning journey. So in the next video, we'll take a look into the measures of position when we are describing the data. So thank you so much for watching, and I'll see you next time.